Hello. In this tutorial we're going to explore the concepts of exceptions and exceptions handling. Now an exception is something that could happen at runtime. It's not an error when the program compiles, but rather it's an error when the program is running and something happens that has to be dealt with. So to introduce this, I'm going to code up a very simple example to demonstrate exception handling. Probably the most simple thing we can do is get a divide by zero error. So I'm going to just simply do a system.out.println on 10 divided by 0. And of course we know that mathematically we can't divide a number by 0. And just to show what's going to happen, this code should never run, because when this line is executed, when this line is executed, it's going to throw an exception and the program is going to halt. So we'll actually never get to this line of code. So let's run this by hitting F6, and we'll see that we have an exception in thread main. We've got a java.lang.arithmetic exception, a divide by 0, which is the problem here. And what's nice is that it shows us that this occurred on line 19, so we can track down and figure out where this exception occurred. Well, it's not enough to just have exceptions. We'd like to be able to handle them. And the way we're going to handle them is by putting potentially offensive code in a try-catch block. So we're going to use the keyword try, and then place the code that might be offending and catch the exception. And then I can say something like system.out.println e.getMessage. Now e in this case is an object of the type exception. An exception is the base class of all exceptions. So you'll see that we had an arithmetic exception, and this exception class will be the superclass of arithmetic exception. So as you'll see in a moment, as I do a different example, we'll drill down and actually catch different types of exceptions. Let's run this one. And you'll see that this is the message, the divide by 0, and then this code should never run actually works now, because what happens is in our try block, if an exception occurs, we can, rather than allow the Java virtual machine to handle it, we can handle it ourselves by catching the exception, and if the exception matches the type, then it will run this code, and that's what's going on here. So we get the divide by 0, which was the message of this particular exception. And then code continues on. In this case, we actually do get our this code should never run. So we should modify this. And if we run now, right, we get good output. So this code should actually run because we handled the exception and the program didn't crash. So exceptions are things that happen at runtime, and we'd like to use try-catch blocks to handle those things when they occur rather than just allowing our programs to crash. So let's dive a little deeper into a more complicated example. I'm just going to comment all of this out, so we don't need it anymore. And let's write a simple program that processes product codes. Continuing on with the theme of the candy bars, let's imagine that every candy bar that we produce in a factory has different product codes, and it tells us when it was manufactured and where it was manufactured and so forth. It's kind of like a born on date. Okay, so let's begin by creating a string code, and we'll need which plant the candy bar was manufactured on. And we've got a different district, so candy bars can be manufactured in different districts, and they each have a unique ID. And what I'd like to do is repeatedly ask the user for these product codes, and I want to count them up and see how many we get from a particular plant. Let's say we're looking for all the candy bars that were manufactured in the Arizona plant. Okay, so I'm going to create a do while loop. So while the code that the user is going to enter does not equal Q, I want to keep going here. So in my do loop, I want to do a system out print, enter product code as plant dash DDD is the district, and then the unique ID. And then I'm going to tell them to type Q to quit if they don't want to do any more here. Okay, now we're getting an error here because the variable code might not be initialized, so let's go ahead and read that in from the user then. So code is going to be equal to, and we're going to want to read in from the user, so let's create a scanner based on system in. Of course, we're going to need to fix the imports on that to use Java util scanner. That's going to add that up here into my code. So I've got import Java util scanner now. And code is going to be equal to next line. Okay, so we're going to read in a string from the user. And if the code is not equals to Q, meaning the user didn't just say they wanted to quit, then what I'd like to do is pull out the individual pieces from this string. So you type in a product code, and I want to pull out the plant and the district and then the unique ID number. So we're going to do some string parsing here. Let's say that the plant is equal to the code character at 0. We're going to pull out the 0th character. Remember, you can consider a string as like an array of characters. So the character at is going to take an index, and in this case I want the 0th character. Okay, so now the plant should be this. The district is equal to integer.parseInt on code.substring, and I want to start at the 2nd position and go until the 6th non-inclusively. So that will pull out this district information here. Notice we do need the hyphens. So this is 0, 1, 2, 3, 4, 5, and I don't want 6. So this second parameter to substring gives me the one just beyond what I'd like to get. Okay, that pulls out the district, and then let's pull out the ID. Integer parseInt on code.substring, and we're going to start at position 7 and go up until position 12, and that will give me the unique ID out of this product code. Okay, so then let's just do a system out println just to verify that we got it. You entered plant and district and ID. So that's just going to verify to us that what we entered is correct then. Let's increment our count and say that if the plant is equal to A, then we're going to increment our plant count as well. So I want, if the user types in an A here, then I'm going to get that this plant count is going to go up. We're going to keep doing this until they hit Q to say they're done and finished. So finally, at the end, I'm going to say you entered so many product codes, and codes from the Arizona plant. Okay. So what this is going to do is it's going to repeatedly ask the user to enter in a product code, and if they don't hit quit, then it's going to break apart all the different pieces and do a bit of counting on what we've entered here. So let's run this, and it's asking us for a product code. So let's say that this is from the New Jersey plant, and the district is 1234, and the unique ID is 99999. Okay, so it says that we entered the plant N and district 1234 and ID 99999. So let's give the next one as the Arizona plant from district 2222 and unique ID 43212. Okay, so entered plant A. If we type in Q to say we're finished, then it's going to say that we entered in 2 valid product codes and 1 code from the Arizona plant, which is exactly what we did. Let's run this again and see what happens if we type in some nonsense here. Right? And we get an exception, the number format exception, because we're trying to parse the int, and that's not possible here. So this is a great opportunity to use our exception handling and make sure that we can gracefully handle these particular problems. I'm going to put this entire code into a try-catch, all within my loop, and let's indent this in. Okay, so after we read in the line, I want to catch some different types of exceptions here. I'm actually going to catch two different kinds and show you the structure of doing this is like so. So I can have multiple catches, and it's going to go from top to bottom and find the first thing that matches and then handle it in that catch space. Once it catches it, it's not going to look at later catches. So make sure that you order your catch statements so that the most specific is up at the top and then the most general would be down at the bottom. So let's look at string index out of bounds exception. And this is going to be the case where I'm trying to find a value, but the string isn't long enough. So I could get that error at this character at, or I could also get it in the substring, meaning I'm trying to get something that's outside of the actual input. Okay, and if that's the case, then I'm going to display a message to the user. I'm going to display the message that the exception had. And then I'm going to display that I got an error and say that the code that the user entered wasn't long enough and display back the code that they got. The other catch that I'd like to have is the number format exception. And of course I can call this whatever I'd like here. I could call this Bob so long as I used it properly down here, but I'm going to call it EX, meaning exception, and say display the message again, and display error district is non-numeric. Or it could be that my plant was non-numeric, so I could say something to the effect of non-numeric value entered plus this code that the user typed in. Okay, so now if I run this and I type in a valid product like Arizona 1, 2, 3, 4, 5, 6, 7, 8, 9, then it's going to say that our plant was A and the district was 1, 2, 3, 4 and the ID was 5, 6, 7, 8, 9. If I say B 999 65656, right, that's perfectly acceptable as well. If I type in some nonsense here, right, we're not going to be able to convert the letters AAAA or the letters YYYY to be integers, so this parseInt here is going to fail. And now notice my program doesn't die. It just says that for this input string, right, we got a non-numeric value entered on this. So let's try it again. And entered in another valid. Right, it could be that I type in something too short. Right? So it could be that it's okay. Right? But then the code wasn't long enough because it wasn't able to get all the way to the 12th spot. So it handles the improper code length and the non-numeric values differently depending on what the error is in my input. And so I can just hit quit when I'm done, and notice that it only counts my valid inputs. If we go up here, I typed in 1, 2, and 3 valid inputs, and 2 of those were codes from the Arizona plant, here and here. So now my program is working quite nicely, and it doesn't crash if the user gives improper input. Now, this will also work in processing data coming from a data file, not just from the user. So keep that in mind as the next tutorial we'll talk about file I/O. One of the nice things about handling exceptions is that it will automatically pass the exception up in the call stack if you have an exception occur inside of a function and that function doesn't catch the exception, then the function will terminate and execution will return to the next function down in the call stack. So you can handle exceptions at different levels, and to demonstrate that, I want to write 3 methods. The first I'm going to call level 1. The next I'm going to call level 2. And the third I'll call level 3. Okay. So each of these methods are really quite simple. I'm just going to say starting level 1, and we'll say ending level 1, just to demonstrate that these functions are being called. And in the middle of level 2, I'm going to call level 3, and in the middle of level 1, I'm going to call level 2. So inside of main, all right, let's comment out all of this so we don't have to run our loop here. And all I want to do now in my main program is call this function level 1, which is going to come down here and say that the method is starting, and then it's going to call level 2, and then it'll show that level 2 is starting, and then it'll call level 3. So this is just a demonstration of function invocation. Level 3 will start and end, and then we'll return back up here to level 2, and then we'll return back up here to level 3, or level 1, excuse me. So if we run this, you'll see that we start level 1, and then start level 2, and start level 3, and then as we're popping off the activation stack, we'll get that we're ending level 3, ending level 2, and ending level 1. Okay. Well, what happens if we do something like system.out.println 10 divided by 0 to get our divide by 0 exception? What will end up happening is that we're not going to see this ending level 3, ending level 2, ending level 1, because the exception is thrown here, and it's going to finish off this function and terminate our program. All right, so you can see that we started level 1, started level 2, and started level 3, but then we got an exception, and the program crashes and terminates. So if I were to put a try-catch here, then it would be handled here at this level, and it would actually say ending level 3, and then it would say ending level 2, ending level 1. But what I'd like to do instead is put the try-catch here at the level 1 to demonstrate that if an exception is thrown inside of a method down here, then this function is going to terminate immediately and come up here. And it's going to terminate immediately and come up here until it gets to a try-catch block. And then it will handle the exception at this level where it's caught, not at levels further on down. So I'm going to catch this exception, and then I just want to demonstrate that I've caught it by saying the exception caught was equal to our get message as we've seen before. But there's also another interesting thing that we can do is tell the exception to print its stack trace, and this will show us where the exception occurred. So that's what we're getting here. Okay, so now I've caught the exception if it occurs, and I'm going to handle it here. So what we'll get is that we're starting level 1, we'll start level 2, we'll start level 3, the exception will be thrown, we're going to drop back here to the catch, and we're going to bypass the ending 3, ending 2, and what we'll get is this output, and then we'll get ending level 1. Okay. So we get starting level 1, starting level 2, starting level 3, the exception was caught, and then here's the stack output right here. And then we get our ending level 1. Okay, so the output is a little bit mixed. That's just an artifact of the IDE here in our output. But the key to understand in this example is that if the exception is thrown further down in functions below, it's going to bypass the return stack and automatically come up here to the catch where we can handle that exception. So this is a way of wrapping a lot of code in one try catch and then handling it up here at that high level. Alright, as the last thing in this tutorial, I'd like to show you that in addition to using your exceptions that are built into Java, we can also define our own exception types. And to do that, I want to go into our older program from a previous tutorial that handled these candy bars. So let's look at our candy bar collection. Right, if you remember, we were using this to manage a collection of candy bars using an array. Okay, we don't need to actually modify the candy collection, but in the main program, what I'd like to do is, let's say, set this to be the active main project. And now if we run, we're going to get this, candy bar collection from the previous tutorial where we could search for candy bars and add them to the collection and so forth. And what I want to do in main now is say something like the big one candy bar here, and let's set the cost to be -1. Okay, so the candy bar is going to cost -$1, and let's set the weight to be -1 as well. Now this doesn't make a lot of sense, but as it's written here, if we run this, then it runs just fine, and it says that the Snickers has 600 calories and it weighs -1 ounce and it costs -$1. That doesn't make a whole lot of sense. So what we'd like to do is come in here into the candy bar class and come into our setter for the set cost and the set weight and say something like, if the cost is greater than or equal to 0, then we can set the cost. And similarly in the weight, if the weight is greater than or equal to 0, then we're going to set the weight. Now one could argue that if you give me a negative value, I could just ignore it. So if we run this now, you'll see that the Snickers retains its original 3 ounces and its original cost of $1.75, even though in main we told its cost and its weight to be -1, so it just ignores those requests. Another alternative would be in the candy bar to actually throw an exception and say, look, you're telling me to do something that doesn't make any sense, and I'm not going to allow you to do that, so I want to actually generate a new exception right here. Now, in order to do that, we could throw an existing exception and generate that, or we could define a new exception ourselves. So let's go in here and add a new class, and I'm going to call this invalid value exception. And it's going to add it into right here. And just like doing inheritance from other classes, I can say that this invalid value exception extends exception, and exception is a base class for all of our exceptions that gives us that get message information. And I could put a constructor here that just calls the super, right? And sets that up. I could also, though, extend this exception rather than just leaving it kind of blank and empty like this. Let's imagine that when an exception is thrown, I want to tag to it the candy bar that you were working with when the exception was generated. So let's create a private value here of type candy bar, and this could be of any type, but in this example I'm having a collection of candy bars, so I'm going to call this reference of type candy bar, and let's create an accessor. So here's my getter. It's just going to return reference. And now I want to extend and add other constructors here. So let's say you pass me a message. I'm just going to invoke super.message, and I'll need to set reference equal to null if you don't pass me anything. And finally, I'd like a constructor that if you pass me a message and a candy bar, I'm going to pass this on, but I'm also going to set the reference to be equal to this candy bar that you pass into me. Alright, now at this point we can go back into our candy bar class, and rather than just ignoring the problem, we can say, otherwise, if you gave me a negative cost, I'm going to generate this new exception. And we're going to use the keyword throw in this case. We're going to throw a new invalid value exception, and I'm going to pass it the message, you can't set the cost to this cost that they're trying to pass in, and I'm going to pass a reference to this here. Okay, and this is the reference to the candy bar itself. Okay, and I want to do the same thing here in the set weight. So I'm just going to copy this down. You can't set the weight to weight. Okay, now the code is proper here, but it's giving me an error. It's saying that we have an unreported exception. Now the syntax here is that since we're not doing a try-catch locally, then we need to mark this function setCost and this function setWeight to say that it throws an invalid value exception. And that indicates to Java that this function could possibly throw an invalid value exception. Okay, and you see that our errors have gone away now. Now what's going to happen is if you give me a negative cost, then it's going to throw this new invalid value exception, which was the exception type that I just defined here. And what's interesting about this is that we have this keyword that refers to the candy bar, so that when we catch the exception down here, it is going to allow us to refer to the candy bar that generated the problem. Okay, so again, we've got this issue where we're not doing a try-catch here. Right, so we need to update our main to actually catch the exceptions that might come out of this. And we're going to catch one of our new exceptions that we defined here. I'll just call it IVE for invalid value exception. And if this happens, I'm going to say system out println IVE dot get message. And since we're inheriting from exception when we defined our invalid value exception, right, back up here to the top, we extended exception, which means that I have all of that capability that a standard exception has, which includes the get message. And I can also say system out println that the error occurred on IVE dot we have get candy bar, which was the method that we defined in the invalid value exception. We have this getter so we can get access to the candy bar that we were working with when the exception was thrown. Okay, now if we run, you'll see that we have the message that comes out. You can't set the cost to -1, and the error occurred on the Snickers. Notice that the Snickers is unchanged here. And that shows how we can define a new exception type and how we can generate a new exception using the keyword throw, and how we can catch an exception of our own making and then use that exception's methods just as we like. Now at this point you might be asking, well, what's the big deal about getting this candy bar reference here in this exception? I mean, you already knew where the error occurred because we've got it right here. So why do I have to go through all the trouble of generating a new exception type to give me that reference? Well, in this case, it's a really good observation because we do have the reference to the object that caused the problem. But what I'd like to do now is close these down and say we've worked with them for enough, fine, okay. And then let's go to another example that we had previously and make this project active. And this, if you remember from a previous tutorial, was our inheritance hierarchy where we had the electronic devices and we had computers and mobile phones and so forth. Right? So in main here, we had our Sony TV and we had our Dell Precision laptops and so forth. And I've commented this out because we're not going to focus on the code that we did have before, but I want to show you that I've added a new exception to this example and extended this example. So let's go through and look at that. I've created a new exception called dead exception, which extends exception. It has a reference to an electronic device, just like we did with the candy bar. The difference now is that I'm referring to an electronic device. I have my getter, and I have my constructor that takes in a message and a reference to an electronic device. So this is nearly identical to that invalid value exception that we just had in the candy bar example. Let's look at the electronic device class though. If we go down here into the use method, if you remember this example from before, we said that if you told the device that you wanted to use, then it's going to get older and it could potentially break. And as it was before, if the age was greater than or equal to its lifespan, then I set alive to false and I just printed out that the device broke. Well, now what I'm actually doing, in addition to that, I'm throwing a new dead exception and saying that the device died at a particular age and it's referring to the device that just died. So when the device dies, I want to throw an exception. Now, let's look at the computer example, which inherits from electronic device, and its use method is nearly identical in that it's going to test to see that if it's still alive, right? If for some random amount of time has gone by, a 1 in 10 chance of failure in this case, then it's going to say that it broke while running too hot, and I'm going to throw a new dead exception that says that it died at a particular age. So I've modified the electronic device in its use. It now throws a dead exception, and the test for break throws a dead exception, and I've added this line of code here, throws new dead exception. In computer, under use, I've added throws dead exception, and that if 1 out of 10 times it should die, then I'm going to throw a dead exception. Now that's all I've changed in the computer and the electronic device code. Here in main, if we go to that again, notice I've had to add the import classes.dead exception here, and main can throw a dead exception. I've commented out the code that we had before, and let's look at what is new. Okay, now I've got an array list of electronic devices, so this is a polymorphic collection, and I add 4 computers into that array list. And then I'm going to display out all of those computers, and then I'm going to make them run. In this case, I'm going to just make the first computer run again and again and again, actually forever, so while true. One could argue that this do while loop should run forever, correct? But the use method inside of the computer is going to potentially raise an exception if it overheats or if it runs for a certain amount of time. So I'm going to put that inside of a try catch. I'm going to catch the dead exception, and if the computer dies, then I'm going to remove that computer from my collection, from this array list. So you can imagine a larger program wherein we have a nice polymorphic collection of all of our animals or all of our electronic devices, and we tell them to do things, and then when an exception is raised, we might want to remove that from the collection. In this case, I have a collection of computers, and when one of them dies, I'd like to be notified of that through this exception handling, and then I'll remove that computer that just died from the collection by this structure like so. When I've handled the death of this computer, I'm then going to redisplay my collection and show that that device has actually been removed. So let's run this, and you'll see here that in the beginning we have, I'm going to grow this a bit so we can see more of the output, that we have 4 computers that have been inserted into our collection, and then the while loop here, this do while true, is going to run the computer for quite a bit of time here, and you'll notice that the del breaks at age 36 comes from the computer here, that it breaks, the electronic device. It runs and consumes power over and over again, and then eventually it's going to break at a particular age, and then it's going to throw this exception, device died. The main program is going to catch that and print out the message, in this case, device died at age 36. And then we're going to come down here and display all of our devices. Notice that after the use, we only have 3 devices, the Dell 2, 3, and 4. Up here we had the Dell 2, the Dell 3, and the Dell 4. So this shows that we're able to manage our collection of computers and remove the one that just died. Okay, so what's the takeaway from these tutorials? We've covered quite a bit here. If we go back into our main that we started with, we showed how to use our try-catch and handle exceptions cleanly without the program dying on us. We then showed in this code how to process user input and catch potential formatting errors if the user's input wasn't what we expected. And then we moved on and showed that if we raise an exception at a level here, we can actually process it at a different level in our program. We then switched into our candy bar code and showed how we can define a new type of exception, in this case the invalid value exception, and our candy bar, if the user gave us a bad cost or a bad weight, we showed how we could raise and throw a new exception of our making. And finally we finished off with an example of defining, again, a new exception of our making, raising those exceptions when, in this case, the device was too old and should die, and in main, catching that exception and removing that thing that just died from this collection. And that should give you some background on exceptions, how to process them using try and catch, how to create them and throw them, and also how to use them in a larger context to process user input and to manage polymorphic collections. And that'll do it for this tutorial.